here in California, we talk about water all the time, but what we don't talk about very often is that using water takes electricity, it takes energy. So the California Energy Commission determined that in 2001, 19% of all energy used in the state was for water-related purposes. So to put that into perspective, that's enough energy for a year to power 5 million homes, which is 39% of the total households in California. So my project aimed to understand this relationship at like a smaller institutional level, using UC Riverside as a model. Unfortunately, a direct comparison isn't possible due to a dearth of metering at UC Riverside, but what we do know is that 45% of Riverside's total greenhouse gas emissions is directly related to purchased electricity. So we decided to determine the percentage of purchased electricity directly associated with water usage. So here on the left, you can see we have a map of UC campus with some points of interest for the 4 main contributors. We have moving potable water on campus, we have moving irrigation water on campus, the heating and ventilation systems on campus, and then all of these combined in the individual buildings on campus. Now, the first thing I would like you to see here is that the findings from the California Energy Commission are scalable. They scale down to the UC level, at least, to an institution. On the high end, we have, you can see, 17%, and this is not exhaustive at all, right? There's a lot of things missing in this list. The other thing I would like you guys to see is the wide range of values and the very confused man at the bottom. So these things are telling us that we don't know a lot. From doing this project, I can tell you we know almost nothing, at least on Riverside, and I'm sure we're not alone in businesses, institutions, the UC level. We don't know almost anything about what we use because we aren't metering, we aren't paying attention to what we're using. Now, this talks about solutions, right? So we can easily improve the amount of water we use, the amount of electricity we use, and in this case particularly, where they meet. You can't manage what you can't measure. A very intelligent man told me this once, and I think it rings true here. If we want to be serious about improving our consumption, improving how we live, we have to begin to measure, understand how we do that. Secondly, we need a centralized system, at least at the UCR level. This data existed across all number of departments. It was incredibly difficult to find and required a number of expertise to read, understand, analyze. So in the middle, I have what I like to call the pyramid of improvement, right? So measuring speaks to the base. We have to begin with measuring. My project speaks to visualizing what's happening. Centralizing our system really speaks to managing and controlling these systems. And together, we can improve what we use without doing anything else. And finally, I think this project really speaks to the fact that technology isn't the answer. This might be kind of a weird thing to say in this room, but the reality is that technology is directionless, right? It is up to us. We have to purposely direct technology with sustainability in mind for a real change to be possible. Thank you.
Okay, I'm coming back from behind the curtain. Do you go by Ben or Benjamin?
Ben.
Ben. All right, so tell us, how'd you get into this project?
Well, actually, my research for my PhD is hydrokinetic technology. So I wanted to look in the piping systems and see if we could do some cool micro-hydrokinetics. But when I went to go do that, I realized we knew nothing about our water system. So I couldn't begin to tell you what kind of cool savings we could have with some technological advancement if we didn't understand what we were using. So my project completely switched, and I just began learning about our water system. I'm pretty sure I know more about the water system at UCR than anybody.
All right, judges, you're meant to be working. Are you still working? Okay. So for the investor judges, we have an example of a pivot here. That's a key word. Extra points, please. Wait, so is this now your PhD project?
No, my PhD work is hydrokinetic weight characterization. Still. Yeah.
How does your advisor feel about the fact that you're doing all this stuff on the side?
He wasn't as happy the first half of the year, but I think I'm bringing him around. I'm bringing him onto the sustainability side, right? Like, he knows it's important, and like for whatever reason, I've become this champion on campus, at least in the engineering department, and he seems to be proud of me. So as long as I keep advancing my PhD work, he'll be fine.
It's exactly where you want to be. If your advisor's not uncomfortable in some ways, you're doing something wrong. Thanks, Ben. Great.
Thank you.